The problem of decarbonization is an urgent global issue. Russia is a country whose electricity market is and will continue to be dominated by traditional energy sources. So in order to reduce emissions and achieve an atmosphere free of harmful gases, it's proposed to create a green hydrogen plant to replace the existing power plant and whose energy will serve to meet the needs of the future programs. The generation of green hydrogen is obtained through electrolysis, a chemical process that uses energy to separate hydrogen from water. These hydraulic plants are the basis of decarbonization. That in addition to using a clean fuel, will generate electricity for industries. Green hydrogen has the advantages of being totally sustainable. It does not emit polluting gases. It is a storable energy, it is transportable, and it can be used not only for industrial purposes, but also for domestic ones. The water will be extracted from the Moscow River located on the site, with the assembly of a small-scale electrolysis stack, and we will be able to carry out the proposed idea. This is a microbial cell, or MFC. It consists of a system of two metal electrodes and two cells. One cell contains the bacteria and has no contact with the outside oxygen, and the other cell is open to the air. The bacteria in the first cell decompose the organic matter, generating hydrogen and electricity that circulates to the second cell. The Living Architecture Group has developed systems for the integrating MFS into housing to create living architecture. These systems are composed of walls supporting a rod, like the ones in the picture, which store the cell and are connected to the building's wastewater system, feeding it and producing electricity and clean water. The thermoelectric effect uses the thermal jam to produce electricity, without the need to use any fuel and without pollution, just by connecting two materials at different temperatures. The snow is collected, supporting low temperatures, which remains on the surface of Moscow for several months of the year. The MFC prototypes are shown up to the living brick, with which we have taken physical data of the brick to see its characteristics, and then a 3D modeling of it to visualize it with more precision. Here is shown the final prototype, formed by the three previous ones. This system consists of an upper support that collects precipitation in the form of snow that is used to generate electricity through the thermal jump, a trunk of living bricks that functions as a structure and as an energy contribution and waste treatment of the building, and finally some lower roots formed by the hydrogen batteries that purifies the outgoing water from the living brick and provides the remaining energy for the proper operation of the building, thus creating a self-sustaining closed system.